Next, we will show the results of our experiments about isolation of flavonoid from rosella flowers. Rosella, or Hibiscus subterrible L, belongs to the Malvaceae family, which is a tropical plant that grows in Indonesia. One of the chemical content in rosella flower is flavonoid. Some medicinal plants that contain flavonoids have antioxidants, antibacterial, antiviral, anti-inflammatory, hypoallergenic, and anti-cancer activities. The study aims to isolate natural chemical compounds from the flavonoids contained in rosella flower extract using ultrasonic methods. The first step taken in isolation of flavonoid compounds from rosella flower extract using ultrasonic method is sample preparation by taking 50 grams of raw powder of rosella sieved with 60 maize. The powder was transferred into 200 ml beaker glass, then added with a solution of methanol and hydrochloric acid with ratio of 98 ml to 2 ml and stirred. The solution that has been formed is ultrasonic to form a paste. Then the paste is filtered using a Buchner funnel and the solution is taken. The solution is then evaporated using a rotary evaporator at temperature of 45 degrees Celsius to thick. Furthermore, the crude extract is pressioned 3 times using a water and chloroform solvent in a ratio of 1:1. The organic solution is taken from the partition, then left into open air to remove solvents that may still exist. Then the product preparation is done using thin layer chromatography or TLC by taking 2 mg of the partition results to be dissolved with 2 ml of chloroform. Then the solution is bottled 10 times on the TLC plate. Then the plate is immersed in a chamber containing the eluent that has been saturated to the end of stain. The stained TLC plate was irradiated using UV light at wavelengths of 254 nanometers and 366 nanometers. From this combustion obtained to stain the are clearly visible, and this is the picture. The result of irradiation of TLC plates with UV light at a wavelength of 254 nanometers produce an unclear stain, whereas irradiation at a wavelength of 366 nanometers, the sample stain looks like a greenish blue and red stain. Presumably, the blue color is the result of flavonols, while the red color indicates Antosianin. The next step is the addition of shear reagents to strengthen the yield of Antosianin compounds before radiation. The addition of hydrochloric acid to TLC plates result in a wavelength smaller than Antosianin, which causes a hypochromic Schiff. Next, add natrium hydroxide and a Schiff to a larger wavelength, photochromic. The final step is identification of the Antosianin compound with a UV spectrophotometer by scraping the stain, which result in the LH Antosianin compound, the dissolving it with technical methanol and hydrochloric acid with ratio 9:1. Then the solution was analyzed using a UV spectrophotometer at a wavelength of 200 until 800 nanometers, obtained a maximum wavelength of 623 nanometers and absorbance of 0.018 and factor rotation of 0.875.
Assalamualaikum warahmatullahi wabarakatuh. We are from chemistry, class C, group 1. Want to show you about our research. And our research is about synthesis of Schiff-based compounds from vanillin and p-anisidin using the drilling method. Schiff-based compounds as synthetic compounds that have various biological activities such as antifungal, antitumor, antituberculosis, antioxidant, and antibacterial, antimalarial also. In this experiment, the synthesis of p-anisidin and vanillin will be carried out using the green synthesis method without the addition of solvent and catalyst. The first step taken in the research of synthesis of Schiff-based compounds from vanillin and p-anisidin using the drilling method are sample preparation by weighing vanillin as much as 0.7608 grams or 5 millimole, and p-anisidin as much as 0.6158 grams or 5 millimole. Mix and crush using mortar and pestle at room temperature for 20 minutes. Here the mixture makes a color paste and then solidifies into a fine powder with a greenish brown color. Take the mixture beforehand and transfer to an empty porcelain cup that has been previously roasted and weigh. Weigh the mixture with porcelain cups, put in the desiccator to a constant weight plus minus 3 days. Weigh, then obtain a weigh yield of 1.2202 grams or 94.89%. The next step is to test the melting point with the MPA or melting point apparatus. From the melting point test, it was obtained 131 Celsius. After that, the synthesis product was test solubility using three solvents, namely water, chloroform, and natrium oxide. From the solubility test, it was obtained that result of perfect soluble synthesis product in natrium oxide solution, which has semipolar properties characterized by a change in the color of solution to yellowish brown and no sediment formed, whereas in water it becomes yellowish and forms sediment, indicating that the synthesis product is slightly soluble in water. In nonpolar color form, solvent the synthesis product dissolve well. The following reaction occur in the synthesis product base with natrium oxide. Next, there is in spectra of the product characterization of synthesis product using FTIR. From this figure, it can be seen that functional groups contained in the product synthesis. Following is the table of the functional group FTIR product synthesis. From the picture above, it can be assumed that the target compound has been formed in the synthesis. Sharp absorption at CNO or carbonyl is a typical path absorption, whereas the synthesis products do not have absorption of carbonyl function group. Absorption of the functional group nitrogen and hydrogen is a typical absorption of p-anisidin and is not present in synthesis product. That is because the nitrogen and hydrogen compounds in p-anisidin has been broken and binds to carbonyl in vanillin to form a new bond, namely the carbon and nitrogen bond or synthesis product. However, the carbon and nitrogen bond formed does not meet the target. Judging from the result, less sharp spectra, this could be due to the scoring done, which is less than optimal, so that the formation of primary amine is also less than optimal, or because there is still water content in the product. The subsequent characterization of the synthesis product using GCMS obtained the chromatogram of the synthesis product. Show that the synthesis product from two peaks. Peaks 1 at retention times 2.174 minutes and had a percentage of the area of 2.3, while at peak 2 the retention times is 23.624 minutes, had percentage area of 97.66. This shows that peak 2 has more dominant level following the peak mass spectra 2. Pigment spectra 2 shows that the molecular ion and base peak are at the value of ampersand 257, which means the molecular ion ampersand 257 corresponds to the molecular weight of the target compounds, so that the peak 2 is 2-methoxy-4,4-methoxy phenyliminomethylphenol. In order to obtain the following fragmentation pattern, the final characterization of the synthesis product is using HNMR. Interpretation of synthesis product using HNMR is shown in the table. Assign Schiff area interpolation splitting.